Hello, welcome to 9.2. Today we're going to look at sampling distributions of p hat. Now, p hat is the proportion we get from a particular sample. The sampling distribution of a population proportion. If we choose an SRS of size n for a large population with population proportion p having some characteristic of interest, let p be the proportion of the sample having that characteristic. Then we know two things: the mean and the standard deviation. The mean of the sampling distribution of p hat is exactly p, and the standard deviation of the sampling distribution of p hat is the square root of p times 1 minus p over n. Those are good things to know. Here's a few notes. The standard deviation gets smaller as the sample size gets bigger. You can tell by n being on the bottom. If this number gets bigger, that makes this whole thing smaller. Since there's a square root on the sample size, multiplying the sample size by 4 will cut the standard deviation in half. Multiplying by the sample size by 9 will cut the standard deviation by a third. Now, one thing to note, the standard deviation formula doesn't always work. Now, it's kind of this formula is good for a lot of circumstances, but it's kind of an abbreviated formula, one that's easier for AP Stats. If you studied statistics further on, you would learn a more complicated formula. But what we need to know for that formula, we use this for the standard deviation of p hat only when the population is at least 10 times as large as the sample. That means population n, this is the population, has to be at least 10 times as big as the sample. Now, a lot of times the population is like the people in America, and you pick 250 people out, so that's going to be way bigger. But where this is a concern is if we're picking a population of seniors in our high school, and we pick a sample of 100 people. There's not 1,000 seniors, so that would violate this, and so we can't use that formula for standard deviation. Now, there's another rule of thumb that we use, and we'll use a normal approximation to the sampling distribution of p hat for the values of n and p that satisfy np being greater than 10 and n times 1 minus p being greater than 10. Now, we've done this before to see if binomials are normal, and it's the same thing with our sampling distribution of p hat. Now we'll actually use some of this knowledge that we just picked up. A polling organization asks an SRS of 1,500 college students whether they applied for admission into any other college. In fact, 35% of all first-year students applied to colleges besides the one that they're attending. What is the probability that the random sample of 1,500 students will be within 2 percentage points of that actual proportion? All right. So we want to find the probability that it's within 2 percentage points, so it's between 33% and 37%. Well, first thing we need to do is find our mean and our standard deviation. Well, our mean is just going to be our p, which is 0.35. Now, our standard deviation, it's going to be the square root of p times 1 minus p over n. Now, p is 0.35, 1 minus 0.35 is 0.65, and let's divide that by 1,500. Now I'll pick out my trusty calculator, and let's see, hopefully it's trusty. 0.35 times 0.65 is equal to 0.2275 if I divide that by 1,500, and then I get a very small number, and if I take a square root of that, I get 0.0123. that's my mean and my standard deviation. So 0.35 and 0.0123. Looks like I made up that standard deviation. 0.123. Oh well. Now we want to show that we can use this formula to find the standard deviation. So let's look back at the problem. It says we want to find that we're looking at college students. So that's our general population, and this is an SRS of 1,500. So what we want to do is prove that n is bigger than 10 of little n. So is my population bigger than 10 times 1,500? Or let's just throw another 0 on that, because 10 times that would be 15,000. So are there more than 15,000 college students? Yes. And if this was a question, you just say yes, because there are more than 15,000 college students. In our population. So since our population is more than 10 times as big as our sample, this is a good standard deviation. Now, is this approximately normal? Let's see how we know. So to see if it's approximately normal, n times p has to be greater than 10. And n times 1 minus p has to be greater than or equal to 10. Well, np is 1,500 times 0.35. And then we'd have to do 1,500 times 0.65. Well, 1,500 times 0.35 is obviously bigger, but just to get actual numbers, 525 and then 1,500 times 0.65 is 975. So both of these are much larger than 10. So yes, it is approximately normal. So NP and n times 1 minus p are greater than 10. All right, so now we got to solve the problem. Remember, whenever we're doing problems like this, we want to draw a diagram, find some z-scores, and then find the probabilities. So we know it's approximately normal. We know it's mean and standard deviation. So what we're looking for is we want to find the probability that the proportion is somewhere between 0.33 and 0.37. So that's the probability that my z-score is going to be 0.33 minus 0.35 over 0.0123 and 0.37 minus 0.35 over 0.0123. So that's going to be 0.02 divided by 0.0123. So that's going to be the probability that my z-score is between negative 1.626 and 1.626. So if I drew this out, here's my normal distribution with it being centered at 0.35, and my standard deviation is 0.0123. So 0.33 is going to be somewhere over here. 0.37 is somewhere over here. So you can see this is going to be a large chunk of the data. I would say at least 85%, but we'll see. So from here I would just do a normal CDF from negative 6.126, negative 1.626, comma 1.626, and I have 89.6, or 0.896. Now, this is how your answer should be written. You have a diagram of the normal distribution. You have the probabilities figured out with z-scores, and now you have a probability. All right, try this one on your own. About 11% of Americans are black. The proportion of blacks in an SRS of 1,500 adults should therefore be approximately 0.11. If the national sample contains 9.2% blacks, should we suspect that the sampling procedure is somehow underrepresenting blacks? Good question. Something that people should look at when they're doing polls. First thing we need to do is find our mean and our standard deviation. Our mean is 0.11. Hopefully I remember that right. Yep. And to find our standard deviation, we take the square root of 0.11 times 0.89 divided by, this is also 1,500. Keep in mind, just because my two samples are 1,500, that's not something that is standard. It's just what my two examples are. I should probably change it so people don't think that's common. So I have a 0.00808. So let's shrink this to 4 digits, 0.0081 for our standard deviation. Show that we can use this formula for our standard deviation. Now, to use this formula, we know that n has to be greater than or equal to 10 times little n. And so this is just like we had before. We just know that our population, there's more than 15,000 black people, so our population is a lot bigger than 10 times our sample. Is this population approximately normal? Let's check it out. NP is greater than 10, n times 1 minus p has to be greater. I'm going to just write this over again. Sometimes I have trouble talking and writing at the same time, which is problematic when I'm talking and writing at the same time. All right, here we go. 1,500 times 0.11. Is that bigger than 10? My trusty calculator says that that answer is 165, much bigger than 10. And so 1,500 times 0.89 has to be a lot larger. So 1,500 times 0.89, that is 1,335. That's greater than 10, so this is an approximately normal distribution of p hat. All right, now try this on your own. Solve this problem. Let's draw a diagram. Where this is 11%, and then we have one that is 9.2%. Well, we need to put our standard deviation, which is 0.0081. So 9.2 is going to be pretty low, 0.092. So what we're going to do here, if we want to see if this is underrepresenting blacks, we want to see what's the probability we get 9.2 or less. It's kind of difficult at first to understand what exactly we're supposed to do in this. But if we find out what the probability of getting 9.2% or less, that would be good evidence whether we're underrepresenting or not African Americans. So we want to find the probability that my proportion is less than 0.092. That's going to be probability my z-score is less than 0.092 minus my mean over my standard deviation. So that's, if I use my calculator again, what's the probability my z is less than negative 2.2 repeating? So I'm going to do an inverse norm from a very low number all the way up to that answer. And that probability is 0.01313 and so on. So about 1.3% of the time this can occur. So should we suspect that this sampling procedure is somehow underrepresenting blacks? Well, now that gets into a little bit more difficult of an answer. Because it's 1.3%, some people might say, it can happen. But most people say that if something happens and it's less than 5%, then that's a rare event. So this is a pretty rare event at 1.3%. So this would rarely happen that a study isn't underrepresenting blacks intentionally or inadvertently, whatever, and come up with that number. So maybe the way that they get their people, it's not reaching the population that they're looking for. Now here's your homework. Good luck.